Buckle up, folks, aviation history is getting a serious upgrade. The skies are about to get faster than your morning coffee run, but without the neighborhood-shaking sonic booms that once scared pets and annoyed grandmas everywhere. Speed has always ruled the skies, but now NASA and Lockheed Martin have built a jet so advanced even James Bond would be jealous. Meet the X-59, a supersonic ninja that slices through the air without waking up half the planet. And yes, China, Russia, and probably every aviation nerd on Earth are watching very closely. A new kind of supersonic aircraft, the X-59, officially known as the X-59 Quiet Supersonic Technology, is not just another plane. Developed by Lockheed Martin's Advanced Skunk Works team in partnership with NASA, it's designed to fly at supersonic speeds over 1,500 km per hour, 937 miles per hour, without producing the explosive sonic booms that historically made supersonic travel impractical over land. Instead of the terrifying boom, the X-59 will generate only a soft thump that's barely noticeable to people on the ground. This major technological leap opens the door for supersonic flights over populated areas, something that was impossible for its predecessors. The X-59. The concept of the X-59 took root in February 2016 when Lockheed Martin secured a contract to develop this futuristic aircraft. Between February and April of 2017, a 9% scale model of the plane was rigorously tested in wind tunnels. These tests examined how the jet would perform at various speeds from just under Mach 1 to about 1.5 times the speed of sound. Initially, NASA projected that the full-scale X-59 would be flight-ready by the early 2020s. However, due to several technical delays, its first flight is now expected in 2025. When operational, this jet could potentially make the journey from London to Sydney in mere hours, without the disruptive noise pollution that once plagued supersonic travel. Why supersonic travel failed the first time? To understand the importance of the X-59, we must revisit the troubled past of its most famous ancestor, the Concorde. When the Concorde made its debut, it captured worldwide attention. Crossing the Atlantic in just 3 hours seemed like the future of air travel had finally arrived, but tragedy and controversy soon followed. A crash involving its Soviet competitor, the Tupolev Tu-144, raised serious safety concerns. Meanwhile, the deafening sonic booms and intense noise pollution led to widespread bans on supersonic flights over land. By 1976, most airlines had abandoned their Concorde orders. Only the British and French governments continued to support the project, with Air France and British Airways as its sole operators. The US, India, and Malaysia even prohibited Concorde flights over their territories because of the noise issue. The financial nightmare of the Concorde. The Concorde wasn't just a technological gamble, it was a financial one too. The initial development cost, estimated at £70 million in 1962, ballooned to between £1.5 billion and £2.1 billion by the time it entered service in 1976, equivalent to £16 billion today. Due to its enormous cost and limited market, only a few Concorde jets were ever produced. The Concorde also struggled with its thirst for fuel. Flying at Mach 2.2, over 2,100 km per hour or 1,330 miles per hour, required enormous amounts of energy, burning 18,000 liters of fuel every hour at cruising altitude, 60,000 feet. The aircraft was constructed primarily from a special aluminum alloy that balanced strength and light weight, which allowed the use of conventional manufacturing techniques without resorting to costly exotic materials, heat, stress, and engineering feats. Flying at supersonic speeds introduced unique engineering challenges. At Mach 2, air friction created severe heat buildup on the aircraft's surface, including its windows and cabin panels. The plane's nose became especially hot, requiring innovative design solutions to endure this extreme environment. The Concorde's metal structure even expanded in flight, growing as much as 30 centimeters, about 1 foot, due to heat expansion. Engineers designed the jet to tolerate thousands of these heating and cooling cycles, stress-testing wing sections to ensure they could handle the repeated strain. One unique feature of Concorde's design was its automatic flight system, which allowed the plane to operate almost entirely on autopilot, from takeoff to landing, using a high-pressure hydraulic control system. Safety at stratospheric heights. The Concorde flew at nearly 60,000 feet, far higher than conventional airliners. To keep passengers safe at this altitude, the cabin was pressurized to mimic the conditions at 6,000 feet above sea level. However, any sudden loss of cabin pressure would have been catastrophic, as passengers would lose consciousness within 15 seconds. The Concorde safety systems included smaller windows to minimize rapid pressure loss and a sophisticated backup air supply. In emergencies, the aircraft could execute a rapid descent to safer altitudes where breathable air was more accessible. The end of Concorde and the birth of X-59. Despite its advanced technology, Concorde's era came to an end in 2003. A tragic crash in 2000, rising maintenance costs, declining passenger numbers, and reduced air travel after the 9/11 attacks led to its retirement. But Concorde's story inspired new innovations, fueling the ambition to develop a supersonic aircraft that wouldn't face the same challenges, primarily the deafening sonic boom. That's where the X-59 comes in. Building the X-59. In February 2016, Lockheed Martin began designing the X-59, and by 2017, small-scale models underwent wind tunnel testing at speeds ranging from subsonic to supersonic. By May 2019, key components of the full-scale aircraft were assembled in California, and by 2020, the jet was halfway complete. One of the most innovative systems tested was the external vision system, a high-definition 4K camera system replacing the front cockpit window. This allows pilots to see ahead while maintaining the jet's sleek, aerodynamic shape. Advanced testing and engineering milestones. NASA conducted extensive tests using scleron imaging, a sophisticated photography technique that visualizes shock waves. This allowed engineers to study how the plane's shape controlled the distribution of pressure waves to reduce the sonic boom. In 2019, the design passed its critical review phase, greenlighting production. By 2022, ENSA installed the aircraft's General Electric F414 engine, a powerhouse producing 22,000 pounds of thrust. Finally, in January 2024, the completed X-59 was unveiled to the public, with full engine tests wrapping up later that year. Its first test flight is scheduled for 2025. If you enjoyed this supersonic journey, smash that like button and subscribe for more mind-blowing tech breakthroughs. Drop a comment below. Would you ride the X-59? And don't forget to hit the bell so you never miss our next high-speed adventure.